Hello everyone, welcome to chemistry class again. Today we'll do the first chapter of chemistry, matter and its composition. Okay? Today we will deal with definition. First we'll deal with the definition of matter. Matter has mass and occupies space. Composition of matter, and if time permits, we will talk about the arrangement of molecules in solids, liquids and gases. Before we start, let us understand what matter is. If somebody asks you what is matter, then you will define it as it is anything that has mass and occupy space. So matter is defined as anything that has mass and occupies space is called matter. For example, air that surrounds you, the food that you eat, the water that you drink, the sun, the moon and the stars are all made up of matter. So matter is anything that has mass and occupy space. Now, everything that we see is matter. But there are certain things we cannot consider this as matter. So not everything is matter. Like for example, heat. Okay? Heat, electricity, sound, vacuum, shadows, they are not matter. Let me repeat it. Heat, light, electricity, sound, vacuum, shadow, they are not matter because they neither has mass nor do they occupy space. Okay? So again, matter is anything that has mass and occupies space. Now let us talk about what is mass. Okay? Mass, by the definition, says mass is the amount or the quantity of matter in an object. Greater the mass, the greater the matter, more the mass. Okay? If a substance has more matter, the mass definitely increases. If the substance has less matter, the mass obviously decreases. So mass depends upon the amount of matter in a body. More the matter, more the mass. Lesser the matter, lesser the mass. So when we talk about mass and weight, there are two different things. Okay? Mass is the amount of matter in an object, whereas weight is the force of gravity of the earth that pulls the body towards its center. That is weight. So there is a difference between mass and weight. Mass is the amount of matter in a body, whereas weight is the force of gravity. Let me repeat it. Weight is the force of gravity that pulls the body towards its center. So mass is the amount of matter, whereas weight is the force of gravity. Please remember that. So mass is the amount of matter in a body, whereas weight is the force of gravity of the earth that pulls the body towards its center. So now we talk about volume. Anything that has mass and occupies space. The space occupied by the body is called the volume. Okay? So all matter occupies space. For example, if you put a stone into a glass filled with water, let me repeat it. if you put a small stone in a glass of water, what will happen? Either if the glass is not filled up to its brim with water, then the level of the water will rise, or if the entire glass is filled with water up to the brim, then the water will, if you put stone in it, the water will overflow. For example, so we have a glass of water. Now you put a stone in it. What do you put? A stone in it. This is the stone. So what will happen? The level of the water will rise. Why? Because matter occupies volume. The matter occupies volume. So what is volume? The amount of space occupied by a body is known as its volume. So, once again, now that we've understood what is mass and what is volume, now the definition is very, very easy. What is the definition of matter? According to its definition, it says matter is anything that has mass and occupies space. Now, composition of matter. When we talk about the composition of matter, matter is made up of very tiny particles called atoms. We have already done atoms in the last chapter. Earlier, we have already done what is atom? What is an atom? For your revision, I would like to repeat it. Atom is the smallest particle of an element that takes part in a chemical reaction. So that is an atom. Matter is made up of very tiny particles called atoms. Atoms are the building blocks of all matter. It is the building block of all matter. They are the smallest particle of an element that can take part in a chemical reaction. An atom usually does not have independent existence. It does not have an independent existence. Therefore, atoms combine to form molecules. So what is a molecule? A molecule is the smallest particle of a substance. It could be either element or it could be a compound over here in this case. So a molecule is the smallest particle made up of two or more atoms combined together chemically. Okay? So matter is either made up of atoms or it could be made up of molecules. Let me tell you again, an atom is the smallest particle of an element that can take part in a chemical reaction, whereas molecule is the smallest particle of a substance. A substance could be element or it could be compound. So smallest particle of a substance made up of two or more atoms combined together chemically is known as molecule. So when we talk about the arrangement of molecules, when we talk about the arrangement of molecules in matter, so before we go to that, we have already discussed earlier in the previous chapters, there are three types of matter. There are three types of matter. What are they? They are solid, liquid, or gases. They are what? Solid, liquid, or gases. So, this is, let's say, solid, and this is liquid, and this is gas. So we will talk about the arrangement of molecules in the matter. Solids. In the solids, the molecules are extremely close to each other. In other words, the molecules are tightly packed, very, very close to each other. Okay? They do not have much intermolecular space. They do not have much intermolecular space in solid. The molecules are very, very close to each other. And the force of attraction between them is very, very strong. Let me tell you again. Solids. In the solids, the molecules are very, very close to each other. In fact, they are very tightly packed. That means it has very, very less intermolecular space. What is intermolecular space? The space between the two molecules. The space between the two molecules is called the intermolecular space. Very less intermolecular space. Why? Why are the molecules very close to each other? Because the intermolecular force of attraction between the molecules. The molecules will have force of attraction. They attract between themselves. There is a force that attracts the two molecules together. This force of attraction is known as intermolecular force of attraction. So, in the solids, the intermolecular force of attraction is very, very strong. That is why the molecules are very, very close to each other. And that is the reason why the solids are hard. They are rigid. They have a definite shape. They have a definite volume. They have a definite shape. They have the definite volume. That is the reason why the solids have definite shape and definite volume. Why? Because the intermolecular force of attraction is very, very strong, and the intermolecular space is very less. And the molecules do not move freely. Since the force of attraction is very, very strong, they are very close to each other. Therefore, the molecules cannot move freely. That means they just vibrate in their mean position. Even if they get energy, they vibrate in their mean position. They cannot move around. The molecules cannot move around. Okay? Now, when we talk about the liquids, in the liquids, the molecules are far apart. They are not very close to each other. The molecules are not very close to each other. Why? Because the force of attraction between the molecules is not very strong. The force of attraction between the molecules is not very strong. So therefore, the molecules are far apart. And they move around within the surface, within the liquid, the volume of the liquid. The molecules do not move away from the surface of the liquid until and unless it gets enough energy by heating it. Okay, so in the liquid, the molecules are not very close to each other, and the force of attraction is not very strong. And since the force of attraction is not very strong, they do not have the definite shape and the definite. They do not have definite shape, but they have definite volume. Okay, and the molecules, they do not move away from this liquid. They move within. They are free to move, but only within the liquid. Now we come to the gases. In the gases, the molecules are very, very far apart. The molecules are very, very far apart. Why? Because the force of attraction between the molecules is extremely weak. It's almost negligible. The force of attraction between the molecules is almost negligible, and they are very, very far apart. That is the reason why gases, they do not have definite shape, nor do they have definite volume. Even though gas is a matter, it has mass and occupies space, but they do not have definite volume, they do not have definite shape. That is the reason why. Okay? So we will discuss from the book. I'll just read it from the book for you. I've already explained the matter. Solids, the intermolecular force is the strongest in the solids. That means the force of attraction is very, very strong in the solids. So the intermolecular space between the molecules in solids is practically absent, and the molecules are very, very closely packed together. So the molecules in solids hardly move about. They only vibrate slightly. So we have already discussed the force of attraction between the molecules in the solid is very, very strong. Therefore, their molecules are very, very close to each other. That is the reason why solids, physically, if you see, solids have definite shape, they definite volume, they are rigid. They are hard. They are rigid, like the board. It's hard. They are rigid. Now we come to the liquid. In the liquids, the intermolecular force of attraction is weak. Therefore, the molecules are not very close to each other. And that is the reason why solids have definite volume but no definite shape. They take the shape of the container. Why? Because the molecules of the intermolecular force of attraction between them is weak. And the molecules, they move within the liquid. All right? Now, when we talk about the gases, once more I'm going to tell you, the force of attraction between the molecules in the gases is very, very weak. It's almost negligible. So therefore, gases do not have, and the molecules are very far apart, and that is the reason why gases do not have definite shape, they do not have definite volume, and the gases can move, the molecules of gases can move anywhere it likes. All over. The molecules will move all over, because the force of attraction between the molecules is very, very large, very, very weak, and therefore they can move around freely. And that is the reason why gases do not have definite shape and definite volume. When we talk about the liquids, I'll just read through it. The intermolecular force of attraction in liquids is not so strong as in the solids. So the intermolecular space in and the molecules are less closely packed. But the intermolecular space in liquids is less than that of gases. The molecules in a liquid can move from one position to another within the liquid. As I already said, the molecules can move within the liquid only. But if you supply it with energy, that means heat the water, let's say. When we heat water, it will evaporate, it will leave the surface of the liquid and it becomes gases. So therefore gases can move freely wherever it wants to. Now when we talk about gases, the intermolecular force of attraction is the weakest in the gases. It's almost negligible. So the intermolecular space between the molecules in the gases is the largest in comparison with liquids and solids. So the molecules in gases are very far apart and completely free to move about in the whole space available to them. So we have dealt with matter and its composition. So we talked about the definition of the matter. We dealt with the matter has mass and occupies space, the composition of matter, and the arrangement of the molecules in the solid, liquids and gas. So in the offline class, I will give you notes on this chapter. Whatever important things are there in this chapter, I'll be typing it down and send you as a PDF in WhatsApp. So thank you so much for joining. Have a good day.